Hi guys, so today we're going to actually review some concepts you guys have already seen and really just kind of combine them together with this new function. So today we're going to focus on inverses. We're also going to review graphing for both exponential and log, but we're going to start by just finding the inverse of some equations. Now as we talked about earlier, log and exponential are inverses of each other. So let's go ahead and find the inverse function. Well, this thing we've been doing all year to find inverses is we switch x and y. So this would become x equals 11 to the y plus 1 minus 4. So I'm going to solve for y. So I would add 4. And then I can rewrite this as a log. Now, I know you can solve this by taking the log of both sides, but because later on we're going to be graphing these, it's going to be really hard to graph it if we take the log of both sides, because it's not going to be something you're used to seeing. So I'm going to rewrite this as a log. So this would be log base 11 of x plus 4 is equal to y plus 1. And it's going to make this much easier to graph. So now my inverse, all I would have to do is subtract 1. So this would be log base 11 of x plus 4 minus 1. All right, so let's look at B. Again, same thing. First step, switch x and y. All right, let's go ahead and divide by 2 so I can get that log by itself. And then I can write this in exponential form. So e to the x divided by 2, or 1/2 x, is equal to y plus 6. So my inverse then, all I would have to do is subtract 6. So e to the 1/2 x minus 6. And again, I like that format because it makes it easy to graph. It makes it really clear what those transformations are. This graph has been stretched horizontally by a factor of 2 and shifted down 6. All right, so now we're going to do the same thing. We're still going to find the inverse, but we're also going to graph both the original and the inverse. So let's start by finding the inverse algebraically. Okay, so the way I'm going to find the inverse, again, we're going to switch x and y. So this is going to become x equals 1/2 log base 2 of negative y minus 2 plus 3. All right, so to solve for my inverse, I need to get that log base 2 by itself. So then what I'm going to do is I'm going to subtract 3. I'm going to multiply by 2. I'm going to leave it factored out just because it'll make it easier to graph later on. I'm going to rewrite this in exponential form. So 2 to the 2x minus 3 power is equal to negative y minus 2. Then I can add 2. And divide everything by a negative to get my inverse. So that inverse is going to be negative 2 to the 2x minus 3 minus 2. And now all I have to do is just graph both of these. Now, it is going to be a little messy with them graphed on the same coordinate plane. I apologize for that. But I do want you guys to kind of see how those are those reflections over the y equals x line. So we'll start by graphing the log function. So to graph that log function, again, I'm going to factor out that negative. I don't know why I put the parenthesis where I did. Factor out that negative, that'll become x plus 2. So that means that this graph has gone left 2 and up 3, and that's going to be my new origin. That's also going to be where my vertical asymptote is. All right, so my log graph, again, this is going to be in relation to negative 2, 3. It's 1, 0, base 1, base squared 2, and reciprocal of base negative 1. So then what I'm going to do is look at other transformations. I've got that reflection over the y, which is going to make these values negative. And then I also have that vertical compression, which is going to divide these by 2. So then from that new origin point, I'm going to go left 1 and up 0, left 2 and up 1/2, left 4 and up 1, and then right 1/2 or left 1/2 down 1/2. So in pink there, that is f of x. And I probably should make that asymptote the same color as well, because when we get to the inverse, I want you guys to see the difference. All right, let's go ahead and graph the inverse. The inverse is exponential. That one has gone right 3 and down 2. So right 3 down 2 is the origin for exponential. That's where the horizontal asymptote is. All right, exponential is 0, 1, 1 base, 2 base squared, and -1 reciprocal of the base. This exponential function, though, has been reflected over the x-axis and has a horizontal compression. So I would divide these by a half. So from 3, -2, I would go over 0, down 1, right a half, down 2, right 1, down 4, and left a half, down a half. And that is my exponential function. So these two graphs, since they're inverses, they are reflections over the line y equals x. So all those x's and y's would be flipped. So again, those little asterisk points we made were flipped x and y's. This -3, 3 point on the log graph is 3, -3 on the inverse graph. Same thing over here. 4, -6 on the inverse is 6, -6, 4 on the original. And those graphs in general are just reflections over that y equals x line. All right, we're going to do one more. This time we'll start with exponential. So to find my inverse, x equals -2, 3 to the y minus 1 plus 4. So -4. Divide by -1/2, and I am going to write it that way because it'll make it easier to see the transformations. Rewrite it as a log. And then add 1. All right, so there is my inverse. The inverse is a log, still has the same base. So now we're going to go ahead and graph them. So we'll start by graphing the exponential. So the exponential function has gone right 1 and up 4. So everything's going to be in relation to that 1, 4 point. So from 1, 4, that's where the horizontal asymptote will be. Then your normal parent function pattern for exponential is 0, 1, 1 base, 2 base squared, -1 reciprocal of the base. So over 0, let's go ahead and apply our transformations. So we've been reflected over the x and vertically stretched by 2. So I'm going to multiply those by -2. All right, so from that 1, 4 point, I'm going to go over 0, down 2, right 1, down 6, and then right 2 down 18 is not going to quite fit on my graph, but it shows you how steep that curve is going to be. And I've also gone left 1, down 2/3. So there's my exponential graph. Now let's look at the log graph. So the log graph has gone right 4 and up 1. So my log graph is going to be in relation to 4, 1. So right 4, up 1, that's going to be where the vertical asymptote is. Log graph parent function is 1, 0, base 1, base squared 2, reciprocal of the base, -1. So then how those points are changing, we have a reflection over the y-axis and a horizontal stretch. So I'm going to multiply these by -2. So from that new origin point, left 2, up 0. And let me make it the same color. So left 2, up 0. Left 6, up 1. Left 18 up 2 is going to be way off my graph, but you get the idea. And then left 2/3 down 1. So that is your log graph. And again, those two functions are reflections over the line y equals x. The x and y's are flipped on all of those points on the graph. All right, so the last thing we're going to do is we're just going to write equations based on transformations. Again, we've been doing this all year. Just a quick reminder, pay attention to the order. The order you apply these transformations in does matter. So we're going to start by translating to the left 2 for natural log of x. So that's going to occur if I'm going left 2, that's going to be plus 2 inside the parentheses. That's f of x plus 2. That's what left 2 is. Then we're going to go up 3. That's f of x plus 3. Then we're going to have a vertical stretch by a factor of 2. So vertical stretch by a factor of 2 is 2 times f of x. That means I take the function that I already have and I multiply that entire function by 2 because it's happening after the fact. So that leaves me with 2 natural log of x plus 2 plus 3. Sorry, plus 6, if I don't put those parentheses. All right, then on my next one, e to the x translated right 5 units. So right 5 is f of x minus 5. So this is going to become e to the x minus 5. 2 units down, that's f of x minus 2. Reflection over the, it got cut off. But I'm pretty sure your notes say over the x-axis. So reflection over the, oh, there it is. It's now showing up on my computer. So reflection over the x-axis. So that is going to be taking everything that I have. Okay, this reflection over the x is negative f of x. So take the function we have and make that function negative. So this is going to be negative e to the x minus 5 plus 2. So again, you just pay attention to the order, make sure you know kind of what transformations you're applying. All right, so that is it for your log graphs and inverses. So to